All right, well, today I'm going to be talking about data quality for artificial intelligence. There's a lot to cover, so let's just jump right into it. A little bit about me to begin with. So like Peter said, I used to run the data platform team at a late stage freight technology startup called Convoy. It's kind of similar to Uber. We have a two-sided B2B marketplace. We stuck machine learning on top of that marketplace, and we were optimizing for route distance, and we provide shipment ETAs and all these other things with our machine learning model. So data was very, very essential to what we were doing at Convoy. Prior to that, I was a team lead on the AI platform at Microsoft. And like Peter said, I am a published author, and I'm working on an O'Reilly book about data contracts. So, all right, I'm sure if all of you don't have your head in the sand, you've seen some doomsday predictions from AI evangelists about how the world of data is going to change over the next 5 to 10 years because of generative models and LLMs and things like this. And here's a few of the comments that I've seen online. There's this belief that you will be able to ask an LLM any question in the business and get an answer, and that answer is trustworthy. And that basically means, goodbye, analyst. You might also be able to ask an LLM to make a prediction. So for example, hey, ChatGPT, build me a pricing model based on a customer's last 5 purchases. And if the LLM can do this automatically, it kind of means bye-bye data scientists. Or we can just ask the LLM to discover product bottlenecks and opportunities. And if that happens, then it means bye-bye product teams. This is the world that a lot of the AI evangelists, I think, want you to believe is going to come true. But I think all of us here, it's a bit preaching to the choir, right? But we know that good artificial intelligence requires good data, and most of the data that is out there is not good. So Mickey and a few of the other folks talking today are going to be focusing on ML ops. So the pioneer, sort of the grandfather of ML ops, is this guy named Andrew Ng. And Andrew Ng is a founder at Coursera, and he also has a venture capital company where he invests in AI-oriented businesses. And what he says is that the most important task of ML ops is to make high-quality data available through all stages of the ML project lifecycle. And so what that implies is that it's not only about this magical model that can do everything, right? You just feed data of any quality or caliber into an LLM and poof, answers, beautiful answers come out the other side. The reality is that any AI system is a combination of code and the data itself. So now that we understand why is data quality essential to AI, what happens if the data is low quality to begin with? Well, number one, you're going to make the wrong predictions. So this is very common at Convoy. We had a model that would predict the potential price of a shipment in our marketplace. And the reason this model was so essential is that the margins for a broker offloading a shipment is very small. So it could very easily become unprofitable for us if the time of year was bad or if the demand was not good for whatever reason. So we had to be very, very thoughtful at bidding on and providing these shipments at scale, or we could easily lose an enormous amount of money very quickly. If your data quality is wrong, our predictions could be bad, and ultimately this could lead to us losing millions of dollars, and that's exactly what happened multiple times. Second, the models themselves may just stop working. It's very easy to blow a model up. Many of the features are very sensitive. So again, at Convoy, we had multiple outages that would be in the 6-figure mark. And sometimes these would happen because an upstream software engineer, like a data producer, would decide to drop a column from a database they maintained that they didn't think anybody was using, and boom, everything downstream explodes. So that's pretty problematic. And then in the case of LLMs, now we're starting to get hallucinations as well. So if you're not familiar with the concept of a hallucination, it basically means that your ChatGPT or LLM or whatever answers a question very confidently incorrectly. So obviously some percentage of this problem is due to the nature of LLMs and how they're designed, but a big part of it is also due to the quality of the data, right? If the model is fed bad data, then it can be very, very confident in providing a wrong answer to a consumer. Okay, so I'm sure all of you here probably have some experience with mitigating or attempting to mitigate data quality issues. Why is this so common in the field of AI and ML? We're doing all of this advanced modeling work. Why is it that the data work, which seems so much more foundational, doesn't seem to be up to par? How many people empathize with this? This is the distribution of data sources and tables and views in any data environment. This is what it looked like at Convoy. We had data flowing in from Postgres databases, from MySQL databases, from ERP systems. That got pushed into a lake. From there, we had various Kafka topics that were picking up data and pushing it into our Snowflake instance. And then there were thousands of dbt models that were exploding all of the time. This is very, very complex. And not many people actually understand what's going on in this ecosystem end to end. The second issue is replication. So if you've got a microservice-oriented architecture, what that means is we are incentivizing, and in fact encouraging, software engineers to build products and applications in an isolated way. And when you're deploying products in an isolated way, it means that you don't really care so much about how the team next to you is building their database. So you might include a lot of the same information that they do. Back in the 1980s and early 1990s, we had this role called the data architect. And the function of the data architect was to be that bottleneck that was helping the production engineers build out their data model. And they were also helping the analytical teams create the data warehouse. But in the modern data stack, the data architect is not playing as big of a role. It's been replaced by this need to move fast, fast, fast all the time. And this leads to replication. The final problem is that the data is always changing. Sometimes, like I mentioned, you might have an application developer that decides to drop a column or change a column or append a new column to their database because they're shipping a new feature and they don't tell anyone. You might have someone creating a new dbt model and they don't tell anyone. You may have a team that decides to implement streaming and they don't tell anyone. So you can imagine you have this incredibly complex ecosystem full of data that is replicated, that's constantly changing. I wouldn't say that it's surprising we have data quality issues. I would say that it's guaranteed that we're going to have data quality issues. So when CEOs and CTOs come to their data teams and tell them that the roadmap will be shifting to generative AI, there's generally two responses. The data scientists that are very, very excited because they're eager to get their hands on LLMs and learn all the sort of cool stuff about them. And the data engineers that have to deal with those three problems that I just mentioned. So if you empathize with anything I just said, you're not alone, okay? I have spoke to well over 100 companies. In fact, the number is close to 800 at this point. And every single team that I talk to, regardless of if it's a BI team, a data engineering team, a data platform team, a data science team, everyone cares about data quality. And generally, someone might even say, oh, well, you know, the next quarter, data quality is going to be the biggest investment for us. This is the next thing on the roadmap. But if you were to ask those same people, is your data trustworthy? The percentage of teams that say yes is very, very small. So something's wrong here. We all acknowledge that data quality is unbelievably important. We all acknowledge that our current data quality is not good. So why are we having these issues? Well, number one is a lack of ownership. So in the modern data ecosystem, like I mentioned, most of the data is being leveraged after the application-oriented use case. Meaning that some software engineer said, hey, I've got an app or I've got a feature and I have some data that I'm collecting for that feature. And they're not thinking about the downstream analytics team or the downstream data science team. And these use cases may not be exactly the same. And so if the data scientists or analysts need some additional data, maybe they need another foreign key added into the data model, maybe they need some level of data quality, no one is raising their hand to take ownership over those problems or resolve data quality issues when they happen. Second, there's no awareness. And by awareness, I mean the data producers have no idea where their data is going, who is consuming it, why it's being consumed, and what the level of quality is that is expected by the downstream teams. So if you're a software engineer and you have no idea how your consumers are leveraging your data, how can you expect data quality? The answer is you cannot. Third is there's no change management, meaning when something changes, and that is a guarantee, there is no way to communicate to the right consumers downstream what is changing, when is it changing, and what is going to be different after it changes. This means that we're constantly caught in a reactive loop, meaning things change upstream, our data consumers realize that something is broken, the data engineer investigates, and then we start our typical mitigation processes. Maybe we write a backfilling job, whatever it might be. But at that point, it's just tech debt. Finally is there's no semantic truth. Data represents something happening in the real world. It's really essential that we understand that. It's not just bits and bytes, it actually has meaning. And if it's not clear to all parties involved what the underlying meaning of the data is, then we don't have the ability to use that data effectively. And all of this culminates in garbage in, garbage out. So I hope everybody knows what garbage in, garbage out is, but it essentially means that once you have low quality data enter the system, damage has been done. All you can do is try to fix it after the fact. And fixing it after the fact is not good enough, especially in an AI-oriented environment. Okay, so we've talked a lot about problems. What are the solutions? Or rather, what are not the solutions? So I am as big a fan of anyone as tooling in the modern data stack. I think tooling is great. However, a lot of the tooling that is available today that people think about solving this problem with doesn't actually solve the problem. So a data catalog is essentially a big index of all of your data assets. Usually it has some Google-like search functionality that helps the data consumers find the data they need and figure out what's trustworthy and what's not. The problem is that the catalog is reactive, meaning that if something changes, you will only learn about it after the problem has already happened, essentially. This is not what we need. Secondly is monitoring tools or anomaly detection tools. I love anomaly detection tools. I think that they're great. However, same problem as a catalog. If you have your monitoring tool set up on your data warehouse or Snowflake instance or whatever it might be, you're only learning about the problems after they've already happened. The entire point of monitoring in the first place, by the way, was to provide near real-time feedback to the software engineer so that they could address issues very quickly. If our monitoring tools are actually not providing that feedback to the software engineers who are causing the problems, then ultimately it just goes directly to the data engineers who still have to deal with this in a reactive way. All right, so you might be saying, okay, that makes sense. But what about like governance committees? Aren't governance committees the right way forward here? I love governance committees. We had a governance committee at Convoy. I ran the governance committee. The short answer is that it's too slow. Governance committees usually involve getting a lot of people on the same page at the same time. So it might be data platform teams, data engineering teams, maybe data scientists, maybe software engineers. And you might meet once a month, potentially at maximum once every 2 weeks, something like that. Again, if you want to make wide sweeping changes throughout an organization or deal with issues when they happen, the governance committees are too slow. You could also have a data engineer sit in every meeting where a feature is being discussed. I think this is actually kind of the ideal scenario. If you have some person who understands the data, able to talk with the software engineers who are implementing the features, that person would be able to figure out, oh, well, here are all the consumers of this data, and here's how you should model it. The problem is that that is not scalable. And it's generally not scalable because the ratio of data engineers to software engineers in an organization is quite unbalanced. In my experience, it's anywhere between 1 in 10 to 1 to 20. If you're a data engineer and this is your responsibility, you would be in meetings quite literally 8 hours a day. So what are our requirements for a solution to solve this problem? Well, you need something that is preventative. It has to be fast to keep up with the rate of deployments in a company, and it also has to be scalable. Enter the data contract. Now, I'm going to describe exactly what a data contract is, but before we do that, what I want everybody to keep in mind is that the data contract is not meant to be a wall. It's not a gate that is completely preventing your software engineering team from making any changes to the data. It's a feedback loop. It's a communication mechanism so that you can loop in the right people at the right time when something changes. So high level, the data contract is an agreement between a data producer and a data consumer on the expectations of the data, coming from the source systems, generally speaking. Very akin to an API. There are 3 core components to the contract: the schema, the semantics, or the business logic of the data, and the SLAs, or the freshness. The data contract needs to be enforced in CI/CD. So a contract without an enforcement mechanism is just documentation. And an enforcement mechanism without a contract is just a test. By combining the 2 of these together, you actually get something that is greater than the sum of its parts here. So the way that this flow works is, and this is how it was working at Convoy, is you have a data producer. That producer submits a PR. You run a check, so you're validating against the contract during CI/CD. If you detect any backwards incompatibility, then you can surface an error message to the producer in that PR and say, hey, you shouldn't be making this change because someone downstream is using the data. There's 2 types of actions that you could take when a contract is violated. The first is informational. So this is promoting data literacy. Our goal with informational changes is that we want to help producers understand how their data is being used downstream and what could happen if they make a breaking change. And a blocking change is pretty clear. If you make a change for a data asset that is essential to the business, you just shouldn't be allowed to do that. You shouldn't be allowed to make breaking changes. But back to what I said before about communication, the major goal here is actually ensuring that the right people are given the right information at the right time. It's all about providing context, not just meaningless alerts in a Slack channel that nobody checks, but actual contextual information that allows people to make better decisions. In our ideal world, we want the data producer to know that a breaking change that they make is not just going to violate a contract, but is going to blow up the dashboard of our CFO. If the engineer knew this before they make the change, the likelihood that they would push through anyway without talking to anyone is quite small. The data engineer, is also essential that they know that some critical data model is being changed. That way that they can represent the data to the producer. And the data consumer needs to know that there's someone upstream that's about to break the dashboard that they're providing to the CFO. Ultimately, this is the person, it's the analyst that's on the hook. So everyone here, the producer, the engineer, and the consumer, all have an incentive to communicate with each other at the time of the PR. And that's because the pull request is the moment where the software engineers are asking for feedback. There is no better time to interject yourself into the product than this, into the process. My belief is that awareness actually is what leads to culture change. If your upstream teams are aware of how the data is being used and who they are going to be impacting, and your downstream teams are aware of who is going to be impacting them, You are bridging the gap between the data producers and the data consumers. So data contracts are not some incredible, otherworldly technical implementation that's solving a big tech problem. They are solving a human problem, meaning people are not able to communicate with each other at the right time. The other really useful thing about contracts is that it helps create a very clear understanding of which data is trustworthy and which is not. So here's our shipment database. Our shipment database our shipment production table has a contract on it. We'll know exactly who the owner of that contract is, what are the constraints of the contract, and if anything changes, then we'll know about it. So at Convoy, we actually had the ability to subscribe to contracts. I mean, you could go to a UI, you could press a button, and if there was any change to either the contract or the resource on which the contract was applied, you were informed about that. Okay, so what do you solve with the data contracts, right? Quick summary. Number one, change management and change communication to 100% of the data resources that are essential to your business. Number two, clearly defined ownership. Number three, the ability to prevent data quality issues before they happen. So at Convoy, we stopped probably 50% of our data quality issues in this mechanism. We are continuing to add more constraints and other checks upstream outside of the PR as well. Trustworthy data assets that everyone in the business can rely on. Awareness from the producer side into how the data is actually being used across the business. Where is it flowing? Trustworthy data models. Explainable inputs. Explainable change explanation. We know why something changed. And being able to scale the data engineering team when it comes to dealing with data quality issues. So we're not just sending a person into every meeting. All right, so let's talk about implementation. The data contract it has two components, the spec and the enforcement mechanism. I prefer to define the data contract spec in YAML, and that's because YAML is a very flexible language. You can easily translate it into the CI/CD checks upstream. In fact, I have some open source tooling that I can tell you about, which manages that translation for you, but that's not for this presentation. There's a few variables I always recommend including in the spec. The first is the actual resource. There should be a one-to-one mapping between a resource and a contract. Number two, the owner. Number three, the expected schema, the data type, and the tier. Now the tier is really important. When I was at Convoy, our tiers ranged from 0 to 1 to 2, and that all corresponded to the level of importance of the data asset. So for our business critical data assets, that was all tier 0, and we would just break the build if the contract was violated. Tier 1 was informational, meaning we would let the producer and the consumer both know if they were going to be making a breaking change. And for tier 2, which was more like experimental data sets, we would just inform the consumer. So we'd say, hey guys, the data is going to be changing. You need to expect this. Here's an example of what the contract looks like. This includes everything that I said. So in terms of the enforcement mechanism, at Convoy, we had checks that were running in CI/CD that would be added by the data platform team. And if you've ever used a product like Sneak, where you can essentially add a check that is looking at a Docker file and saying, oh, okay, are we following our security best practices? It was a very, very similar process for adding these types of data quality checks. Which was very useful because we weren't actually dependent on the software engineering team to implement contracts. The data platform team and the data engineering team could actually do this themselves. And what we would do is we would check the output of a migration in the developer environment and simply compare it against what was defined in that contract. And if it was backwards incompatible, then we would take one of the actions that I showed you before. We had other different types of checks as well. So we had checks for forwards compatibility, but there were new columns that had been added. So that was a bit later in our contracts. We still had communication mechanisms for this as well, where we'd say, hey, your data is not being broken, but there's some new field that's been added. You should probably check it out and talk to an engineer about this. Here's an example of the alerts that we would show if a contract was violated. Very, very simple to start off with, as you can see. So schema is not compatible with the contract. There's a missing required property. And because all of these contracts are stored in a single Git repo, it was very easy for us to request modifications. So any data consumer could do this. They could open up the Git repo. They could say, hey, I would like to put another column under contract, and here's the constraints that I would like. And ultimately, that was just a PR. That PR would get reviewed by the software engineering team, and that software engineer could decide if they wanted to include that constraint in the contract or not. So where do you implement data contracts, right? I've talked to a lot of companies about this, and I definitely have some opinions about how to get started. Contracts, in my opinion, are not intended to be horizontal layers, meaning we say we need to go to every data source that we have, and we need to put a contract there. That is an enormous amount of work. And B, I don't actually think it's incredibly useful. There's so much data in a company that if it were to break, no one would really be impacted by it. Especially these days where we have these data lakes, where I think I read a statistic that 75 to 80% of all the data in the lake isn't even being used by anyone. And so putting data quality checks on things that nobody is using is just going to make the engineering team go slow. Our goal here, like I mentioned, is to communicate context to the producers. And context is only meaningful if the data is being used in a meaningful way. So I like creating contracts vertically through a pipeline. At Convoy, we had this concept of a tier 0 data service. And this basically meant that the data was being used in a way that impacted the customer, or it was some other very, very high value use case. So it could be accounting data. It could be our machine learning models. It could be data that we were actually literally surfacing to a customer. All of these were the places that we started implementing contracts first, and we would go end to end. We would start at the source systems, we would figure out the lineage, what are all of the inputs to this data asset or data product that's downstream, and we put contracts on all of those things. And that's what we call the production grade data pipeline, meaning there wouldn't be any change in that pipeline that the consumer or the data engineer supporting that product would not know about. I mentioned before that I don't think catalogs and monitoring are the answer in and of themselves. But I do think that they actually work really, really well when you incorporate them into a system that is leveraging data contracts. So at Convoy, we were using an open source data catalog called Amundsen, and we forked it, and we started indexing all of our data catalog. We're indexing all of our data contracts into the catalog. And we started enriching all of our catalog metadata with contract metadata. The number of violations to a contract, whether or not a contract had been, whether or not there was ownership over the contract or not. And the same goes with monitoring. So the metaphor that I like to use about implementing monitoring systems without data contracts is it's kind of like implementing Datadog without GitHub. You're gonna get a lot of noise. However, if you have a data contracting system in place that's handling a large part of the preventative issues, then you have this really nice feedback loop where issues that maybe you don't account for in your first version of the contract, you can still catch downstream, and you can feed those back into the contract as additional constraints. The other reason that's really useful is because you're not just presenting constraints in the contract for no reason. You have some basis for it. It's like, hey, we've got a data set, and we experienced this data quality issue. Here's the evidence of that as measured by our monitoring tool. Now there's a really good reason to incorporate that, to enforce that upstream. So the number one question that I probably get about data contracts is this one. Don't you need to change the culture first? And that's not quite the way that I look at this problem. So this is a question that I like asking, which is if you were starting at a new company tomorrow, and that company was not agile, right? They were still doing sort of waterfall software development and moving very, very slowly. Imagine you had two methods of convincing the engineering team to change to agile. Method number one is by going and talking to each individual product team and teaching them about the Agile Manifesto, walking through the 14 points or whatever it is, saying, hey, we should do this. It's really useful. Or the other option is you start by incorporating Agile engineering best practices and technologies. Version control, CI/CD, GitHub, Jira, yada, yada, yada. Well, the difference between these two options is, number one, the first creates process, and the second creates value. I think that process is really important. It's unbelievably useful. However, it is much, much easier to layer process on top of a team that's already it's already very easy to do the right thing than trying to layer process on top of a team where doing the right thing is very, very hard. So if you don't have version control, if you don't have CI/CD, if you don't have Jira, then asking the engineering team to suddenly switch to this very iterative mode of software deployment is unbelievably difficult. That's a really hard thing to do. So why are data contracts useful? Well, it's because they make the transition to producer-owned data quality easy. Like I mentioned before in a previous slide, every stakeholder in the value chain has something to gain from the implementation of contracts. It allows the data engineering team to scale, and these are usually the people who have the most incentive to implement these things. The consumers can now see when they're going to be broken in advance, and they can self-advocate. And then finally, the producers have visibility. So you don't necessarily need to start off by requiring a contract to be accepted. You can simply propose it and allow the engineer to see where their data is flowing. This is something that was really interesting that happened at Convoy, where once our software engineers started understanding where the data was going and how it was being used, and they got a list of 7 or 8 different consumers, well, then before every change that they made, they had 2 options. Either they could go and have a conversation with all 8 or 9 or 10 people who are using their data, or they could just take the contract. So the data contract actually makes life much easier for the data producers, but only after they become aware of who's using their data. That's it. That's my presentation. I hope you all enjoyed that. I don't know if we have time for questions or not.
We certainly do. Does anyone want to ask Chad any questions? Not everybody at once. Oh, we got one.
You're obviously speaking a lot there about systems that are built in-house. When sort of theorising about how these things would work in our context, one of the big challenges is we have an ever-growing list of SaaS providers who love to change stuff and go fast and break everything that we build.
Yes.
So interested in your thoughts on whether or not this would work in an environment with SaaS providers, and if so, how would you modify the approach, I guess?
Yeah. So you are right in that this approach does not work very well with SaaS providers because it requires that the producer and the consumer get on the same page. However, I think that you can still use the approach of a contract in conjunction with testing after the data lands. So I've seen a few interesting approaches to this. One was you have a sort of landing zone table for your data that's coming in from one of these providers. Once the data lands at the row level, or maybe in sort of a larger batch, whatever, you run a set of checks. You see if the contract has been violated, and if it has not, then you push that data through to your production pipeline. And if it has, then you leave it sort of in that holding zone, and you alert a data engineer to come in and fix something. The other option I've seen is when you actually allow all the data through, but you append a column. And that column contains some JSON data about the contract violation, so that the consumer downstream at least understands whether or not any particular row is high quality. So not quite as good as a contract because it's not preventative, but still good in the sense that you're empowering the downstream consumers to understand how data quality affects them.
Cool. Anyone else?
One more thing to say on that. I will say that there are some SaaS providers where you can implement contracts, like Salesforce is one example. They actually expose they have a product called Salesforce DevOps, I think. and they expose their CI/CD workflow. And so you can insert a circuit breaker either when some Salesforce administrator is making a schema change or someone is doing data entry that violates a contract. So I didn't implement this, but I know that there are other teams that are doing it. Yeah.
So data contracts is such a fascinating idea. Based on your experience, what you say would be the biggest challenge for large organizations to actually implement this?
Yeah, I would say the biggest challenge is, so I think there's a couple things. I think I had to go through a lot of painful learnings to figure out the right implementation strategy. And I think that sort of is also where a lot of people run into issues with this. So for example, one implementation of data contracts I've seen is that the team will say, data producers, you're actually not allowed to emit any data into an analytical environment without a contract. I think that can work. However, it can also create some misaligned incentives where maybe the producer team says, hey, look, I don't want to go through the effort of creating a contract for all of the data that I maintain, and so I'm just not going to admit a large part of that data, and that obviously has negative ramifications. So yeah, I think that's sort of the biggest issue. Is like exactly what is the right rollout model. From my experience, starting with the informational piece and just helping the producers know where their data is going is the best way to ultimately get to contracts. The other issue that I've seen before is that honestly just fear on the side of the data platform and data engineering teams. It's still, I think, not a common pattern for a data person to write like a data quality check on code that they don't own. This is a very common pattern in other areas of the business, but in data, it's still not that normal. So I think people are very, very sensitive about stepping on toes of software engineers, and that can sort of lead to a lack of adoption as well. Yeah.
How would you compare this approach to others like data mesh?
Yeah, so my opinion, and I am biased, but my opinion is that data mesh doesn't work without data contracts. I'm not sure how it would work. I think that there has to be some equivalent. If you're sort of framing the world of data as microservices, I think there has to be some equivalent of an API, and that's exactly what this is. Now, I think that if you can culturally get the organization to move towards data mesh without sort of necessarily requiring all the data literacy, then maybe some of the informational pieces that I just mentioned aren't as necessary from day one. But in general, like I do think that some level of contracts are required, and Jamak even says this in her book. It's like you need to have some level of contracts, some type of data-oriented API. Yeah.
In terms of implementation culture, because when we implement the data contracts, we slow down a bit of the process of ingestions because of the data quality issues. Will there be any slowdown of the process of ingesting data because of the PR failures, because the data is not as per the quality? Does who owns up the cleaning up process, and because it will be in contradiction with the implementation. I mean the project's goal, because ingestion slows down. So how do we find the sweet spot? Because if the data quality is really poor for all of the data, we won't be ingesting any of them, and we'll be spending a lot more time only on cleaning it up than ingesting and bring business value to the analytics team. So that's my question.
Got it. I think I understand. So was the question about? Was it about where do you start with the rollout, and how do you, if you've just got a lot of data that you need to think about at this sort of ingestion?
What's the trade-off or the cutoff? Or what's the sweet spot point to decide, okay, let's take this or let's not take this? Yeah.
So, I mean, this is, I think it really comes down to what data the business values the most. I like preferring to do things in a very incremental way. The more incremental, the better. And when we were at Convoy, we actually started by asking our data consumers. So we put out a poll to our data consumers and said, of everyone that relies on data that our platform team provides, where is there the greatest need for data quality? And then we went to those teams and said, I want you to quantify the impact of data quality on the work that you're doing. And so then I had a number, and I could say, all right, so if you had, now that I understand like what the impact of this work is going to be, I want you to tell me, what are the 2 or 3 columns, like not even schemas, but like what are the 2 or 3 columns where this data contract would be very useful for you, like as incremental as possible. And that could be like a customer ID field, like, oh, this always needs to be not null, and it always needs to be an 8-character string. And if we just got that, it would radically improve the lives of the consumer. And then once I have a win, then I can take that back to the business and I can say, hey, look, this is the value that this team got of adding a data contract on a single column. Imagine if we did this for an entire pipeline, right? That's kind of how I framed it.
Cool, all right. Thanks very much, Chad.